Hi, welcome to your lesson on solving systems by any method. So use your imagination, kids! All right, which method is best? We began solving systems by graphing. Graphing is always good, but sometimes the intersecting point or solution is hard to get exact values for. There's an example of that. Here's these two lines. They intersect right there. But unfortunately, that intersection point is not at the corners of the grid, so it would be some decimal values. And I'm left thinking things like this. What is the solution? Is it 1.8, 3.3? Let's see, 1.8 maybe, 3.3? Or is it 1.7, 3.2? I don't know. So the algebraic methods we used are much better because they give us a precise answer. We don't have to guess exact values like this. So let's look at this one. Which method is best? If we ignore graphing and we just concentrate on substitution or elimination, then we look at this and say which is best. Well, in this case, check it out. It's pretty easy to do substitution because it's easy to solve for x in 1. When I put in 1, I mean in equation 1. Here, to solve for x would be pretty easy. You just do plus y and it would move it over there. It's also easy to solve for y, but solving for x is really easy because when you add y, y becomes positive, everything's positive. That makes a really easy substitution. So you would solve this one for x like this by moving the y over here. See how the y has moved over. And then you substitute that into the second equation. So in here, that x has been replaced by that, and then we would continue from there. All right, in this one, let's take a look. Which method is best? Ponder that for a second. Well, I think definitely substitution again, because both of these are already solved for y. And if these are solved for y, then you can just make a quick substitution. So what I'm going to do is, here's equation 1, and here is equation 1 substituted into 2. In other words, this y value here has been substituted to replace this y here. And we're left with basically setting the two lines equal to each other. And you proceed from there. How about this one? Take a look. All right, well, definitely combination. That's another word for the elimination method. That combination method or elimination would be best here. Anytime you have coefficients, which means numbers in front of the x and the y, then combination or elimination is easier because when you have these numbers in front, if you were to do substitution, you'd have to move something over and then divide by that number and then get those fractions that make it kind of tougher than maybe it should be, right? So I'm using the word cumbersome. It becomes cumbersome. That means like kind of inefficient or full of different objects and things. So combination would be better here. We could multiply the first equation by 5 because that will turn this into a 15, and we can multiply the second equation by negative 3, because that will turn out to negative 15. And then you would have your two equations that look like this, and if you combine these, or put adding of these two equations, the y's would be eliminated. So that's a good technique for that. Next one, we have which method is best here. So take a look. What do you think? My suggestion is substitution, right? Because again, we have these x and y values here, and both have no coefficient, and in that case, it's very easy to solve for x or y. So it says, number 1, equation 1 is easy to solve for both. Let's see what I did. Oh, I solved for y, so I moved that x over to that side. I have 1 minus x. Now I know what y is, and I can substitute that into the second equation. So that y has been replaced with that 1 minus x. And then you'd proceed from there. Take a look at this one. Well, I would suggest combination, which is elimination. Once again, we have coefficients in front of x and y. So in that case, it's much easier to find how we can eliminate things. So I would say here, one way to do this would be multiply the second by 3. Because if you multiply this by 3, it will turn it into 12. And then we'll have a negative 12y and a positive 12y, and those will be eliminated. So let's see. Here's our first equation, remains as it is. Second equation has been multiplied by 3. Everything's been multiplied by 3. And now when you combine, those will cancel. So when you add them up, it shows you are left with that, and you can solve very quickly. Great, one more. Well, I would say combination or elimination again. Even though we have this x by itself here, if we were to solve for that x, that y would move over there. Then we would have to divide or multiply everything by negative. It's not difficult, but in this case, combination might be the best. Multiply the second equation by negative 4. Why did I choose that? If you multiply this by negative 4, you'll have a negative 4x here, but this times a negative 4 will turn into a positive 4. So those two will be eliminated. So here's our first equation, unchanged. Here's the second equation after it has been multiplied by negative 4. Everything's changed. Now these two, when you add these two equations, these two will be eliminated and we'll be left with y's and we can solve. Great. Oh, did I say last one? Well, here's the last one, I think. All right, substitution's good here. Again, when you have just a simple variable by itself, substitution is very easy to do. So I'll take the first equation and solve for x by adding 5y to both sides. So here's a 5y. And then you take that, what we just found out x is equal to, and substitute it into the other equation right here. So that x has been replaced with that. And then you continue from there. All right, let's take some notes now. So you were given a paper before you left class. On here, we're going to do some notes for a quick lesson, very quick lesson. We're going to look at all four methods. Again, there's graphing, substitution, elimination, and then there's using your graphing calculator. We haven't done that yet. We'll do that in class at the end of the week. So here's the first system given to you, and it says, so even though we just looked at, choosing which method is best and so on, I want you to practice all three methods together and just see if you can get to the same solution. So let's do this one by substitution. So again, this is a good one for substitution because we have a variable here with no coefficient. So I'm going to solve this equation for x. And I'll do that by subtracting 7y here and subtracting 7y here. And then I have this. All right, now you have a equation for x that can be substituted into this x value here. So that x has been replaced by all of that. We're left with an equation with only y. X variables have been eliminated. So let's multiply through here and see what happens. Negative 4 times negative 14 makes a positive 56. Negative 4 times negative 7y makes a positive 28. And then we have the rest here. Now we can combine the y's. 28y minus 14y makes 14y. Now we can subtract 56 from both sides to isolate this y. So minus 56 minus 56. And that is gone now. We have 14y. This becomes negative 28. And finally, you divide by this coefficient here. Divide by 14 and divide by 14 here. So y equals negative 2. If we know y, we can substitute that back into here. Well, into here, here, or here, because this is just another version of this equation. So I'm going to put it in here because that'll give us x right away. So x equals negative 14 minus 7 times negative 2. And we have x equals 0, actually. This cancels away here. So our solution is 0, negative 2. That's the point where these two lines will meet if you graph them. All right, so now let's take the same system and solve by elimination. Looking at it that way, we can eliminate the y's or the x's. It doesn't matter. It's your choice, really, which one you want to do. I decided to multiply by 4 here. That means this will turn into 4x, and then I'll be eliminating the x values. All right. So when I multiply this by 4, I get 4x plus 7y. That's not right. Oh dear, what's going to happen? That's not right. Or interesting that the answer worked. That's strange. Let's pause. All right, we're back. Let's try again. I fixed a little typo there. So multiplying that by 4. Now that equation becomes 4x plus 28y equals negative 56. We have our second equation unchanged. We're going to combine those to do elimination. Add them up. When you add these two, you eliminate the x. When you add those two, you get 14y. And when you add those two, you get negative 28. Divide by 14, and you get y equals negative 2. So elimination gave us the same y value. Now that we know y, we can take it into either equation. So I'm going to put this equation here, substitute that negative 2 in for y here. And that shows us x equals 0 once again. So our solution matches the solution we got by when we did substitution. And now let's try the same one by graphing. So here's our two equations again. To graph, we need to change to y equals mx plus b form. So this one, I need to solve for y, and this one I need to solve for y. So to solve this for y, I'm going to minus x, subtract x here, and then subtract it on the other side. So I have negative x here now, and negative 14, and 7y is alone here. Now I'm going to divide by 7 to get rid of that 7. So when I divide by 7, I divide this by 7. Right now this is negative 1, so now I have negative 1 over 7. This was negative 14. When I divide that by 7, I get negative 2. So there's the first equation of that line. Let's graph it. This number here is our b value, right? If this was y equals mx plus b, this would be our y-intercept, negative 2. And then we'd have a slope, negative 1 over 7. So I can go down 1 over 7 or up 1 over 7. Either way kind of takes me off the graph. I'm going to go up 1 over 7. I'm going to put that somewhere over here and connect them. All right, it's kind of off the graph, but there it is. Second one, let's solve this for y. I'm going to isolate the y, so I'm going to add 4x on both sides to move the 4x over. So now I have negative 14y, and then 4x was moved to this side, so I put it here, 4x plus 28. And now I'm going to divide by negative 14 in order to get just y. Divide by negative 14. So what happens when you divide 4 by negative 14? You'll have 4 over 14, but I reduced that to 2 over 7, and it's negative because we have that negative there. And then when you divide 28 by negative 14, you get negative 2. So let's graph this one. Our y-intercept is negative 2, so it's going to be the same, actually, y-intercept as that one. And then the slope is negative 2 over 7. So you can go down 2 over 7 or up 2 over 7. I'm going to do that. I went up 2 over 7, and then there's our line. And you can see, yes, they meet at that point because they have the same y-intercept, so they actually have a solution right there. And that's the solution we found all 3 ways now. So 0, negative 2 every time. So your job is only to do one problem on the back, and it's the same way. Like I said, we'll look at next time how to solve systems on our calculator. Of course, you could graph it on your calculator and find the point of intersection, but there's another way also to solve systems when you're given the equations in this form, which is called standard form. There's a way for your calculator to do it very quickly for you, and we'll show you how to do that next time. So now this one's on the back. You're going to solve by elimination. To solve this by elimination, I'm going to request that you, well, you know what? You go for it. And then do all 3 methods, get the same solution. Let's see what solution you get. All the best. There's no other assignment. This is your only homework.